This video is recorded for Hunt for India's Best Academic Project contest organized by Crazyengineers.com. I am Shum Shukla along with my teammate Kunal Banchal.
Hello everyone.
We are from Parul Institute of Technology from Vadodara in Gujarat. Our project title is Electronic Steering, Electronic Differential and Traction Control of an Electric Car. I would like to start my presentation with statistical data on road safety scenario in India. Every year, more than 4.4 lakh road accident cases are registered, of which more than 1.4 lakh led to death. That means, in one day, more than or approximately 381 people die in road accident. Worst part is, as number of vehicles on road is increasing day by day, the percentage of car accident is also getting worse. Although safety features like seat belts, airbag, ECU, ABS system are available, but all these features are only available in high-end model cars. So basically, if we include all these features in every car, the cost of a normal car will increase by much percent. So this can be a problem to both manufacturer and consumer in big market like India. So there is a need for some innovative ideas to bridge the gap between cost and safety factor of a car. First idea on board we have is electronic steering. Basically, we know how the power steering in a car works. The steering of a car is connected with a pump and pump is connected with the car engine. And whether you steer your car or not, because the engine is running, the pump will continuously pump the fluid, and this in turn wastes the fuel of the car, which makes the car less fuel efficient. So by means of electronic steering, we can make sure that car is more efficient. The second idea on board is electronic differential system. So differential system basically means that every wheel in a car, every individual wheel in a car receives the amount of power it actually requires, not less or more compared to other wheel. So now let's see how the differential system actually works. Now consider you are driving a car. Now you are taking the turn with the path. So basically this is your inner wheel and this is your outer wheel. So as we can see, the inner wheel is supposed to cover less amount of distance as compared to the outer wheel. So basically the outer wheel requires more amount of power as compared to inner wheel. So this is where electronic differential system comes in the equation. Now let us see the third idea what we have. The third idea we have is traction control system. Consider you are driving your car on a slippery surface. Now as you are driving on slippery surface, when you will accelerate your car, the vehicle won't move forward because there is less coefficient of friction maintained between vehicle, wheels and road. So traction control system basically makes sure that there is optimum coefficient of friction is maintained between the road and wheels, so that your car without any slippage it moves forward, and traction control system also makes sure that there is no power wastage due to slippage, and it also makes car more stable and efficient.
How are we going to achieve this thing on field? In several experiments carried out on road, it was found that if the slippage of the wheels is limited up to 20%, maximum traction would occur on wheels, after which increasing the slippage would decrease the grip between the road and wheels. So we need to design a logic that would simply limit the slippage of the wheels up to 20%. So this is the suggested solution for the traction control of an electric car for rear wheel drive cars. For electronic steering, if we consider the curve execution diagram of the car, after a little mathematical investigation, we found that to execute a real curve, one wheel should steer a little more than the other. Normally this wheel is the dominant wheel. For example, if we are turning right side, then our right wheel should steer more than the left wheel, as you can see in the diagram. Now this phenomenon has got a name called Ackermann. So performing this job by using electronic servo motors will give driver the freedom to define the degree of the Ackermann. Let me give you an example. If you are driving the car in sports mode, there is a need to completely remove the Ackermann phenomena where both the wheels will align at same degree. So So this can be done by just a push of a button. Now, finally for the electronic differential. If you observe the co-execution diagram of the car mathematically, it is seen that while turning, the inner wheel has to cover smaller distances and the outer wheel has to cover larger distances, as shown here in the diagram. Now, this necessitates the uneven distribution of the power to the rear wheel drives of the car. This is done by the onboard computer, which is being fed to the two separate DC motors mounted on the chassis of the car. Now, if any of the above features miscalibrated in the car or absent, may result in serious harm to the chassis of the car or may result even into the accidents. Now, we have the testing phase video of our practical model car. Please see. First reason why our project should win, as the future of automobile has started shifting towards the reign of electric car, it necessitates to bring on all the best features presently available on ICE engine car to electric car, or even better than that. Well, we have stepped into it, so according to me, our project is well worth it.
The second reason why our project should win is that, as we all saw, the road safety statistics in India is getting worse. So, there is need for a practicable, innovative solution which can be implemented in all the cars for safety purpose, and this project provides the one. So, we conclude our presentation that